The definition of this thing is rational functions are quotient of polynomial functions. Quotient of polynomial functions, they mean it is basically one polynomial one polynomial divided by the other polynomial. That's what it means. Quotient of polynomial functions mean it's one polynomial divided by the other polynomial. This means that rational function can be expressed as, so fx is my rational function which is equal to some polynomial px divided by another polynomial qx. The only condition is my denominator cannot be 0. So that means my this qx, this cannot be a 0 polynomial. It has to be something. That's what it means. Example I'm going to take of rational functions is if I say fx is equal to x square minus 9 over x plus 3. Or other could be fx is equal to x over x minus 3. Or other could be, I can say, third example could be if I say hx is equal to x plus 3 over x square plus 9. There are various different examples. I can take so many examples of rational function. But these are the examples. So basically one polynomial divided by the other polynomial. But make sure my denominator cannot be equal to 0 because that makes it undefined. If I have my denominator as 0, it makes it undefined. So I cannot have my qx as 0. Okay. Next thing what we're going to talk about is domain of rational functions. Domain of rational functions. How would you find the domain? How do you find the domain is whatever is in the denominator. Whatever is in the denominator, put it equal to 0. Whatever is in the denominator, put it equal to 0. In this case, I have x plus 3. Let's say I take example A. I call it A. So you had x square minus 9 over x plus 3. I say find the denominator of this thing. So you take that thing, put that equal to 0. Whatever is in the denominator, put it equal to 0. Solve. You get x is equal to negative 3. So this is your real number. This is your real number line. Okay, and this is your 0. Okay, and I say negative 3 is here. When I put my denominator at 0, I am getting x is equal to negative 3. What does that mean? That means if I put negative 3 here in this problem here, if I put negative 3 here, my denominator will become 0. And I don't want that. I don't want that because by putting the negative 3 as 0 here, by negative 3 putting here negative 3, this makes it 0. That makes it undefined. So this part is not included. Everything else is included in my domain except this part. So how do you write it is from negative infinity to negative 3, open bracket. And from negative 3 to infinity, open bracket. Negative infinity, infinity always have open bracket. And on negative 3, you're going to put open bracket because that point is not included. Everything in between here is included. Everything in here is included. But not that point. Anyone who did not understand how to find domains, just put your denominator equal to 0, solve and exclude that point from the domain. And one die?
Yeah.
I have to find the domain for the second one. How do I do it? I have x over x minus 3.
You do the denominator, so you do x minus 3 is 0, so it'll be x plus 3.
Yes. And then what will be my domain?
It will be negative infinity to 3.
Yes.
And then 3 to infinity.
Perfect. Perfect. Just put that equal to 0. Whatever you get, exclude that from the domain. By putting this open bracket, you are excluding it. Daniel? Gerald? Erica? Joshua?
Yeah.
So I need to find the domain for the third one. What do I do?
So you would set it as x squared equals -9.
X square is equal to -9. Okay.
And then square root both sides.
Square root both sides.
And it would be x equal, would it be plus -3?
No.
Or would it be positive?
So you are correct. You're going to put plus minus sign. That's correct. But okay, this becomes x. What is square root of -9?
3i.
Yeah, it's I. You cannot find a square root. It will go into imaginary. It will go in whenever you have a negative number inside a square root, it goes into imaginary. So that means in this case you cannot. Note, we are talking about real number. We're not talking about imaginary numbers. So in this case you cannot find any value of x which will make this as 0. Which will make this as 0. So my domain will remain as -infinity to infinity. You can make a note whenever we have a negative number inside a square root, the real value of x does not exist. So you can make that note for yourself. Whenever you have a negative number inside a square root, the real value of x does not exist. So in this case, my domain remains -infinity to infinity. I want everyone to do these problems by themselves. So you are given A as fx is equal to x square minus 25 over x minus 5. B, you are given x over x square minus 25. And then C, you are given hx as x square plus 25. Do these three problems by yourself. Oh, sorry. X is equal to x plus 5 over x square. And you can call this hx. You can boil, stay there. You can boil the eggs and keep it so that later we can eat it. Yeah. Christopher?
Yes.
Okay. What do you get the answer for first one?
X cannot equal 5.
So what is it?
So it's negative infinity, open bracket, comma, negative, or just positive 5,
Okay.
and then parentheses, 5, comma, infinity.
Perfect. You go.
Yeah, so I got parentheses, negative infinity,
Negative infinity to?
comma, negative 5,
Okay.
parentheses. I'm not sure about this, the union sign,
Okay. Yeah. Perfect. Yeah.
negative 5, parentheses, negative 5, comma, 5,
Perfect. Yes.
the union sign again, and parentheses, 5
To infinity.
to infinity.
Perfect. Miguel. Not here. Angel. Not here. Samantha.
Who?
Yeah. Samantha. So what's the answer for the last one?
Wait, did you call me?
Yeah.
My Wi-Fi is slow. It would be negative infinity to the positive infinity.
Yes. Correct.
The video is lagging.
Is it for everyone like that?
According to the chat.
Oh, yes. Oh.
You'll
Yes.
glitch me free sometimes. So like we won't hear something you say and then you go up to something else.
Oh, maybe it's my internet connection today then. Okay, if it happens, let me know. Or I can repeat myself. If it, does in the middle and you guys don't understand, just let me know. I'll explain again. So let's see what we're next thing what we're gonna do is we're gonna learn how to graphing rational functions. So for graphing rational functions, you need few things here. First thing you need to know is how to find the vertical asymptote. First thing you need to know is how to find vertical asymptote. Does anyone know what is asymptote? Anyone?
Nice too.
Asymptote. ASYM. It's M. PTOTE. Asymptote.
Like a line?
Yeah, it is. You know what it is?
Part of the graph dotted.
It's when the graph approaches it but never touches.
Yes, exactly. So if my graph is like this, suppose I say, my graph is something like this is my asymptote here. I say this is my asymptote here. It's a line. If this is my asymptote, my graph will go very near this line. This is my graph here. This is my graph. It will go very, very close to this asymptote, but it will never cross this asymptote. If I keep on extending, it will go very, very near, but there will be no point where it will cross. So that's what asymptotes are. My graph goes very near to that thing, but it never crosses. So what we are going to do is we're going to find the vertical asymptote for the graph first. We need to figure out what is a vertical asymptote. How you do it is, so I wanted to write here, locating. Make sure you make notes of all this because this is not in your books. They're not explaining it properly in your books, this thing. Locating vertical asymptotes. How do you do it is if px over qx is a rational function in which px and qx have no common factors. So with one very important thing, no common factors. I want you to underline this word, no common factors. Okay, and a is a 0 of qx, the denominator, then x is equal to a is a vertical asymptote of graph f. That's what it says. So it says if px over qx is a rational function in which px and qx have no common factors, there should not be any common factors between them. If there is common factors, you need to get rid of the common factors first. That's the first step, to get rid of the common factors. And then
Can you repeat that?
okay, whatever you have in your, if you have a numerator and denominator, first thing what you're gonna do is, if they have any common factors, is there anything common between them, common factors, you're gonna cancel them. You're gonna get rid of the common factors. And then what you'll do is, whatever is your denominator, whatever is in the denominator, you will put it equal to 0. Find the value of x. That will be your asymptote. That will be your asymptote. That's the difference between domain and vertical asymptote. Is in domain you just put denominator equal to 0 and solve. But in case of vertical asymptotes, you have to first see if there is any common factors or not. If there isn't any common factors, then you can cancel, and if there isn't any common factors, just put denominator equal to 0 and you'll find your vertical asymptote. But in other case, you have to simplify and then find it. Examples, I'm going to do examples, don't worry. Hopefully everyone is done copying that definition. So let's see, if I say fx is equal to x over x square minus 9. X is equal to x square over x over x square minus 9. You're given this thing. And they say you have to find the vertical asymptote. In this case, there's nothing common between them. Okay, I would say, remember this thing. This thing is, we will be using this very often. Remember, we had a square, remember we did this, a square minus b square is equal to a plus b, a minus b. Remember this thing. This property is something we use very, very often here in this case. Okay. So in this case, I can make factors of this thing, x square minus 9. I can write x square minus, can I write 9 as something square? Anyone can I write 9 as
3 squared.
3 square? I can write 9 as 3 square. That's correct. You got this thing. So what's going to happen in this case is, now my a is x and my b is 3. If you compare the formula. So what does it become? X over, note, if I use this formula here, it becomes x plus 3, x minus 3. This is the maximum I can simplify. Is there anything common between numerator and denominator? Nothing. So I cannot cancel.
Okay.
I cannot cancel in this case. I cannot simplify further. So what I'm going to do is, I'm going to directly put my denominator equal to 0. If I cannot simplify, just whatever your denominator was, put equal to 0. And then solve. You get add 9 both sides. You get x square is equal to 9.
Nicely.
Yeah. And then square root. When you're taking square root yourself, make sure you put a plus minus sign. So you get x is equal to plus minus 3. So if I have to graph this, this is my negative 3, this is my positive 3. On this I will have my vertical line. So I'll make a dotted line there. In this case, I have to make a dotted line like that. Let's take more examples. We'll take more examples on this. So next thing you have x plus 3 over x square minus 9. You have to find vertical asymptote for this one now. Again, whenever you're finding vertical asymptote, first thing you're gonna do is you're gonna try to simplify. On the numerator, I cannot do anything, but in the denominator, I can try to open it and make it into factors using that formula here. When I do it, it comes out to be x plus 3 and x minus 3. These are the factors. Now, can I simplify? Is there anything common between the numerator and the denominator? Yes, there is x plus 3 in the numerator and there is x plus 3 in the denominator. I can cancel them. When I cancel, what I'm left with in the numerator? Anyone?
1. X minus
1, because I got cancelled, so I'm left with just 1. So your answer is 1 over x minus 3. Note, this is your new problem now. This is your new question now. You'll be working on this, not the previous one now. Now what you have to do is find the vertical asymptote. You have to put the denominator equal to 0. You get x is equal to 3 only in this case, not negative 3. So on 3, you will get a dotted line. So that's a tricky part in this thing. You have to try to simplify. Let's do one more question. So you have x plus 3 over x square plus 9 in this case. If you have to find vertical asymptotes, first you have to try to simplify it as much as you can. Let's see. Okay, numerator I cannot simplify. X square plus 9. I cannot make factors of x square plus 9 because the formula is x square minus something, not plus something. So I cannot make into factors in this case. So it remains as it is. And there is nothing common between this thing and numerator and denominator. So I cannot cancel anything. So whatever is in the denominator, I put equal to 0. Try to solve it. X square is equal to negative 9. Take square root on both sides. Put a plus minus sign. You get x is equal to plus minus square root of negative 9. You cannot find a square root of negative 9. You will not get any real answer in this case. So that means no vertical asymptotes. So in this problem specifically, you will have no vertical asymptotes. Anyone has any questions with vertical asymptotes? Okay, if you have done this, I want you to do these problems by yourself. So you are given a as fx is equal to, I want you to find vertical asymptotes for all these. X square minus 1, b as fx is equal to x minus 1 over x square minus 1, and c you are given as hx is equal to x minus 1 over x square plus 1. Try these 3 problems by yourself right now. Jose? Jose,
Yeah.
what's the answer for the first one?
1 and -1.
1 and -1. So basically your graph is going to look like this. So if your 1 is here, -1 is here, then I have a dotted line here, dotted line here. Okay. Alejandro? Alejandro? Alejandro?
Oh, he said earlier his speaker didn't work.
Yeah, I want to
so
see.
he couldn't.
The thing is, I want to see his speaker is not working if he's replying in the chat. He's not even replying in the chat. Alejandro, if you're here, I want you to reply in the chat. If your speaker is not working. Axel? Axel is not here. Jelena is not here. No. Carly?
Yeah.
Yeah. Carly, what did you get for the second one?
For the second one, I got the asymptote is -1.
X is equal to, you're getting -1. Perfect, yes. We'll get that. So it will be just -1. Because you have to simplify. When you simplify, you'll be left with just x plus 1 at the bottom. So can you, Alejandro, type the answer for the third one in the chat. I want the answer to the C part in the chat. I want the answer for the third one. Guys, turn on your videos. I want everyone's videos on.
You need an answer for C, right?
Yeah, C. Yes.
It's going to be 1 over x plus 1.
1 over x plus 1. Why? Can you tell me, Eduardo?
Because the x squared plus 1, we're going to turn it into its original factor. So it's going to be x plus 1.
Mm-hmm.
And then the other one's also going to be x plus 1.
No, you cannot do that.
Oh, yeah, sorry.
The thing is, it's x squared. If it's x squared minus 1, then you can make factors. But since it's x squared plus 1, you cannot make into factors. Note the formula is a square minus b square, not a square plus b square, which changes into a plus b, a minus b. But in this case, here it's a negative sign, but here I have a positive sign, so I cannot make into factors. So it will remain as it is. It will remain as it is. And if you try to simplify it, if you try to simplify this, x squared plus 1, you put that into is equal to 0. Try to solve. Subtract 1 both sides, you get x squared is equal to -1. Take square root on both sides, put a plus minus sign. You get x is equal to plus minus square root of -1. Square root of a negative number, not defined. Not defined. That means no vertical asymptotes in this case. Did you get it, Eduardo?
Yeah.
So this was about vertical asymptotes. Next thing is about, we have something known as horizontal asymptotes also in rational functions. Horizontal asymptotes. Horizontal asymptotes. So their definition is, let f be the rational function given by, so you're given a rational function, let f be a rational function given by, they say fx is equal to, they say an x to the power of n plus an minus 1 x to the power of n minus 1, so on up to a naught, and my denominator is something bm x to the power of m, so on up to b naught. They're saying there are two polynomials, they are just writing in the way of polynomials. Don't get confused, or why are they writing like this? They're not writing px over qx. It's okay, they just expanded the polynomials. Okay. What they say is, what you're going to do is, the degree means the highest power. You can say highest power of x. Highest power of x in the bracket if you don't know what degree is. The degree of numerator is n, and note your an, it cannot be equal to 0 and bm cannot be equal to 0, because if that's 0, that then degree is not nmm. Okay, they say the degree of numerator is n and the degree of denominator is m. If you're suppose in the question you have some problem, you say the degree of the numerator is n and degree of the denominator is m. You find the degrees. Find the degree of the numerator, find the degree of the denominator. Now there are three conditions. Three conditions could be that n is less than m, degree of numerator is less than denominator. What happens when they have equal? And what happens when it's greater? So when it's less than m, my numerator has less than denominator, you should directly know your vertical asymptote is your x-axis or y is equal to 0. This whole line, x-axis or y is equal to 0 is your horizontal asymptote. If it's equal, what you're gonna do is, the line y is equal to, you have to find the line what? Y is equal to what? You're gonna take the coefficients of the highest degree, which is an in the top one, and divide them. That is your horizontal asymptote. And if the degree of the numerator is greater than the denominator, no horizontal asymptote. No horizontal asymptote. I'm going to take examples on this and then we'll see how to do it. So fifth. Okay. So suppose you're given, I'm given these three examples. Fx is equal to 4x over 2x square plus 1. You are given this problem here. I say you have to find the horizontal asymptote. For horizontal asymptote, what's the degree? So I need to find degree of numerator and I need to find degree of denominator. Axel? He's not here. Samantha? Shaira?
Yes.
Okay. Shaira, so can you tell me what's the degree of numerator?
That's 4, right?
That's 4. Yes, that's 4. Yes.
1,
Okay, 1. And what's the degree of denominator, Shaira?
2,
Yes. So I'm saying my n is equal to 1 and m is equal to 2. In this case, my degree n is less than m. 1 is less than 2. When it's less, what happens? I directly know my x-axis is my answer or y is equal to 0. They are the same thing. So if this is my graph and I say I have to graph my horizontal asymptote in this example. That's my x, this is my y. I'll just make this line as dark. This is my horizontal asymptote. My graph will go very close to x-axis but will never cross x-axis in this case. Let's take one more example. If I have 4x square over 2x square plus 1. 4x square over 2x square plus 1. Then Karen?
Yeah.
Okay. What's the degree of numerator?
2.
Denominator?
2.
Okay. What happens when it's equal?
The line
Y is equal to?
y.
Yeah, y is equal to?
2 over 2.
So, no. So, what's the coefficient of this one? What's the coefficient? So, you take the constant next to x square. Since x square is the highest degree, that will be
Okay.
4. And what about the bottom one? What about the denominator? What will I take?
Okay, 4 over 2.
Yes, perfect. So, you get y is equal to 2. You're like, how do I know where is the line y is equal to 2? So, first of all, let's see. I know y is equal to 2 is definitely this point here. If this is 2, I say this is this point. But it's going to be a line. It will not be a point, it will be a line. How do you draw it is make x, y. I don't have x. My y is always 2. No matter what, my y is always 2. If you don't know how to draw y is equal to 2 line. No matter what I take my x, my y will always remain as 2. 0, 2 is here. 1, 2 is going to be here. 3, 2 is going to be here. And this is going to be my line. You make dotted line, okay, not the solid line. This is dotted line. That's your horizontal asymptote for this example. Guys, this is the only
that part you don't include the x squared with it, like 4x squared over 2x squared, just 4 and 2.
yes, just the numbers. Just the numbers. Okay, let's do one more part. I want to do one more part and then you guys can do it. 4x cubed over you have 2x squared plus 1 was
Yes.
okay. What's the degree of the numerator
3.
and denominator?
2.
Okay. What happens when my n is greater than m?
It will have no horizontal asymptote.
Perfect. No horizontal asymptote. Perfect. For rational functions, the only tricky part is to find these two things. Once you got these two things, the graph is really easy. The only tricky part is to find the horizontal and the vertical asymptote, which we did right now. So I'm going to write some problems. I want you to do it yourself. You need to find horizontal asymptotes for A. Fx is equal to 9x square over 3x square plus 1. B. You need to find for Gx is equal to 9x over 3x square plus 1. And then C you need to find for Hx is equal to 9x cube over 3x square plus 1. I want you to find the horizontal asymptote for all of these three. Nick? Nicholas? Nicholas, are you there? Axel, write the answer for the second one. In the chat. Hawking, I want everyone's microphone to be working next time. If you don't have it, please go. You can contact Southwestern College. They're going to provide you a laptop or something in case you don't have anything.
This is Joaquin. Which one would you like me to do?
Okay. Can you tell me the first one?
The first one, I got the degrees were equal.
Mm-hmm.
So then I just divided the coefficients.
What did you
and
get?
I got 3.
Y is equal to 3. Yes, perfect. How would I draw a line here? Okay.
Like a constant
Yes.
horizontal line at y equals 3.
Perfect. You got it. Yes. Yeah. Okay, let's see. What did he say for? You have to find the horizontal asymptote for this one. For B1. Okay, C, can I have Christopher?
Yes.
What's the answer for the C part?
For C or B?
C.
C. So N is greater than M
Okay.
because N is 3 and M is 2. So it would be no horizontal asymptote.
Perfect. No horizontal asymptote in this case. Actually, you're giving me answer to the B1. Horizontal asymptotes. In next lecture, I want everyone's speaker working. So basically what you're going to do in this case, what's your N? What's your M? You have to find it. I'm wasting too much time on this if you don't have speaker, guys, and I don't even know you are doing your work or no this way.
M is equal 1
Yes.
and M2.
Yes. What happens when your N is less than M?
The Y is equal 0.
Yeah, or x-axis, the same thing. So basically, so if this thing is your thing, your x-axis, so make a dotted line on the x-axis itself. That's your answer. Perfect. So now we are gonna go to the main steps of how to find the graphing. So these are the steps, main steps. So start writing this: strategy of graphing rational function. Strategy of graphing rational function. So the following strategy can be used to graph fx is equal to px over qx, where p and q are polynomial functions with no common factor. I want you to underline this: no common factor. So first thing what you're gonna do is you're gonna simplify. If some polynomial rational function is given to you, first thing you're going to do is simplify as much as you can. And then you're going to start the steps. Okay. Step 1. Step 1. Okay. It says determine whether graph of f has symmetry. You have to check for the symmetry first thing. How do you check it is, wherever you see x, replace it with negative x. Wherever you see x, replace it with negative x. If it's equal to the same fx you had in the original question, if it's the same as the original question, then it is symmetric with respect to y-axis. Y-axis symmetry. But if you replace it with negative x and it comes out to be negative of fx, that means sign of each and every term changes. Sign of each and every term changes. It is symmetric with respect to x-axis. So first thing what we're going to do is we're going to check with the symmetric, whether it's symmetric or no. How do you check? Replace it with negative x. Replace your x with negative x in the original function. If it comes out to be exactly as the original function, it's symmetric with respect to y-axis. But if when you replace and sign of each and every term changes, sign of each and every term changes, then it is symmetric with respect to x-axis. That's a step 1. You're going to do problems, you'll get this. It's like, and then you have step 2 as find the y-intercept. And we all know how to find the y-intercept. How do we find y-intercept? Anyone?
Substitute x with 0.
Yes, substitute x with 0. Step 3. Find x-intercepts. Find x-intercepts. You know, in case of x-intercept, what you're going to do? You'll say, oh, we put y is equal to 0. We do put y is equal to 0, but what we do in this case is, you just put the numerator equal to 0. Since my numerator was px, I will just put the numerator equal to 0. So right here, just the numerator equal to 0. You just have to put the numerator equal to 0. For x-intercept, just the numerator equal to 0. Step 4. I say you have to find vertical asymptotes. Vertical asymptotes. What do? You put denominator equal to 0. We just did that. I don't have to simplify because that was my first thing. My question is already simplified. So you simplify that and you put, for vertical asymptotes, you put denominator equal to 0. Step 5. We need to find horizontal asymptotes. So for that, you're going to look at the degrees. You're going to look at the degrees. If n is less than m, x-axis or y is equal to 0. If n is equal to m, y is equal to an over bm. If it is greater, no horizontal asymptotes. Then step 6. Step 6 is, so this is important, plot at least one point between and beyond each x-intercept and vertical asymptote. That's what they want. You have to plot at least one point between and beyond each x-intercept and vertical asymptote. That's it. These are the steps you'll be needing to graph a rational function. Example, we're going to do an example. I say you're given fx is equal to 2x minus 1 over x minus 1. Okay, first thing is, can I simplify this? Can I simplify? Don't say, oh, I see x minus 1 here, x minus 1 here, I cancelled. No, you cannot cancel like that. That's not the factors. Factors is something multiplied by something. But in here 2x, you're subtracting 1. But at the bottom in x, you're subtracting 1. In the numerator, you had 2x, which is different from x. So you cannot cancel them. So don't cancel here. You'll be wrong. You can only cancel if it's a factor. 2x minus 1 is not same as x minus 1. That's wrong. Okay. So let's do step 1. I cannot simplify this. I cannot simplify. So next I'm going to check is for symmetry. Step 1 is to check for symmetry. How do you check it? Is replace x with negative x. So I replace it. Wherever I see x, I'm going to write there as negative x. It becomes negative x, negative 1, which becomes negative 2x, negative 1 over negative x, negative 1. You get this thing? Okay. Compare. When I compare this, okay, my original question was 2x minus 1. Here I'm getting negative 2x, negative 1. So that means it's not symmetric with respect to y-axis. I definitely know it's not symmetric with respect to y-axis. To y-axis. But I need to check with respect to x-axis. Let's see. For x-axis, I told the terms for the numerator, for each and every term, the sign should change. And the bottom should remain same. Let's see. No, here only the 2 sign is changing, not the negative ones. Negative 1 still remains the same. The sign for each and every term of the numerator should change, but in this case it's not changing. Only the 2 sign is changing. It was positive, it became negative, not for the negative 1. Negative 1 still remains negative 1. So it is neither, not symmetric with respect to y-axis. X-axis.
Does it also have no symmetry within origin?
What was? I didn't get your question.
Does it also have no symmetry with origin?
Yes, not origin. No. Perfect. Yes. Just a second. Wait, guys. Can you change this? Wait. It's supposed to be origin. Guys, I wrote here x-axis. It's supposed to be origin. You're correct. Thanks for correcting me. Guys, in the step 1, it's supposed to be, you're checking for y-axis symmetry and origin symmetry. You're not checking for x-axis symmetry. X-axis is different. I got confused here. You're correct. Thanks for correcting us. So you're checking for origin. So it's neither a symmetry with respect to y-axis nor origin. Okay. Let's go to step 2.
Wait, can you explain how it's not origin symmetric?
Okay, so what you got, let's see what I'll explain here. So you got your fx was 2x minus 1 over x minus 1, right? When you replace with negative x, what are you getting as this thing, correct? And Monday? Okay. Can you tell me, are these two functions looking exactly the same? Exactly the same. That means it's not symmetric with respect to y-axis.
Oh.
Okay. Can you tell, is this function negative of this function? Negative means sign of each and every term is
No.
changing. No, right? So if it's like this, negative of fx, what it says is negative of fx, I'm going to write here like this. Then it's symmetric with respect to origin. How do I check? What happens if I take out a negative sign outside? I take out a negative sign outside in one die. What happens? When I take out negative, what does this become?
X minus 1.
2x
Oh, the 2x 1, the 2x minus 1.
plus 1, plus 1.
Or plus 1, okay.
It signs changes, right?
Yes.
So that's why it's saying, and then here it becomes
X plus 1.
x plus 1. Are you getting it? It's not the same, right? It's not the same. Is it same as original function?
Oh, it needs to match exactly. that
Exactly.
original.
With a negative sign
Okay.
outside. Since it's not matching exactly, it's not gonna be the answer, okay?
Okay.
And wait
Thank you.
here, when you change the sign, when you take out negative outside, only the numerator changes, not the denominator. Denominator still remains the same, okay?
Okay.
Yeah, only the
Gotcha.
numerator sign changes, not the denominator. Anyone who did not understand the symmetry part, if you guys are not understanding, ask me, I'll explain again. Anyone who did not understand this part, how to check with y-axis or origin symmetry?
Maybe like one example or something like that.
Yes, we'll be doing more examples on this. We'll be doing more examples on this. I'll be taking one more example on this. We'll be doing, okay. Let's see, I will do, but let's go to step 2 and then I'll explain this again. Okay. You have step 2 is to find y-intercept. For y-intercept, we just know put x is equal to 0. So your original question was fx as 2x minus 1 over x minus 1. Put x is equal to 0. So you get f of 0 is equal to 2 times 0 minus 1 over 0 minus 1. So you get negative 1 over negative 1, which is 1. Let's start graphing. Let's start graphing. So this is my graph here. I'm drawing. I just found my y-intercept. Y-intercept. How do I say my y-intercept as? Anyone? How do I write my y-intercept as?
You mean your point, 0, 1?
Yes, yes. You write a point like that. Yes. 0, 1. So y-intercept you got is as 0, 1. Mark that point. Y-intercept is just a point. Mark that. I marked it. So I got my 1 point on the graph. I definitely got my 1 point on the graph. Let's go to step 3. Let's go to step 3. Step 3 is to find x-intercepts. Anyone for x-intercepts, what do you do? If you see your steps.
Set the numerator to 0.
Yes. Put y is equal to 0, but no, make sure in this case, you usually put y is equal to 0, but in case of rational functions, you just put the numerator equal to 0. So whatever is in your numerator, just that you're going to put equal to 0. In this case, I had function was given as 2x minus 1 over x minus 1. For x-intercept, whatever is in the numerator, just 2x minus 1 I will put equal to 0. Just that thing. So when you solve, you get plus 1, you get 2x is equal to 1 divided by 2, you get x is equal to 1/2. And how do I write my x-intercept as? This thing. It's a point. It's not a line. It's a point. 1/2, 0. So it's going to be somewhere here in the middle. I mark my that point. Start marking my that point. Okay. Step 4. Vertical asymptote. Anyone vertical asymptote?
1.
Yes, you put denominator equal to 0. In this case, my denominator is x minus 1. Put that equal to 0. You get x is equal to 1. Note, asymptote is not a line. Asymptote is just, not a point. It's a whole line. It's a whole line. So if you don't know how to draw this line, no matter what, my x remains 1, you can take your y as anything and plot those points. 1, 0 is gonna be here. Okay, 1, 0 is here, here, here. So it's gonna be like this. And asymptotes you make with a dotted line. You always make asymptotes with a dotted line and make an arrow. Any doubts till step 4? Step 4, anyone has any doubt till step 4? Okay. Step 5. You have to find horizontal asymptote. Horizontal asymptote. Now here you're given the function. You have to find n and m. You have to find your n and m. Okay. Joshua. Joshua?
Yep.
Yep. What's your n and what's your m?
N would be 1 and M would be 1.
Okay. What happens when they're equal?
When they're equal, it's 1 over 1.
Not 1 over 1.
It's 1 divided by 1.
No.
Isn't it AN over BN?
Yeah, an. What's a an? What's the coefficient of degree 1?
Oh, is it 2?
Yeah, 2 over,
Oh, it's 2 over 1.
which is 2. Y is equal to 2.
Yeah.
Note, this thing is a line. It's not a point. It's not a point. It's a line. No matter what, my y remains 1, whatever I take my x as. So if you plot this, you will get a line passing through y is equal to 2. And it will get a straight horizontal line. Make a dotted line. My graph is never gonna touch this. My graph is never gonna touch this. Asymptotes. Okay. Any doubt with step 5? Okay. Step 6. Step 6. It says you have to take points between x-intercepts and your vertical asymptotes. So basically what are they trying to say is, if that confuses you, what you're going to see is, you look at your graph. You look at your graph. While you're plotting, you look at your graph. Look at just your x-axis. I'm just going to look at my x-axis here. And I'm going to start making a table. I want to start making a table here. I'm going to write it like here. A second. So this is my graph. I'm going to start making my table. I'll make a table x and y. I'll start making my table. Just look at your x-axis. Assume nothing else exists. Just look at your x-axis. Okay. If I see my x-axis, I suppose this is my x-axis here. The first point I marked here. The first point I marked here was 1/2 0. Okay. On the x-axis. The next point I see is here. This point, my graph is crossing at this point. 1 0. My graph is crossing at this point. They want you to take points between and beyond. So you're going to take point before this, between this, and after this. You're going to take all those points. You're going to take points before this point, between those points, and after those points. Take any point before 1/2. Take any value of x before 1/2. Anyone, any value.
1/4.
1/4. Why you want to deal with fractions? Why not exact numbers? Take any number. Take anything. 0,
-1.
-1. Yes, exactly. You can take -1. You can even take 0. 0 comes before that. You can even take 0. But you are taking -1. That's perfect. Let's take between 1/2 and 1. Any number between 1/2 and 1. Anyone?
1.
Between 1/2 and 1.
3/4.
3/4.
3/4.
3/4. If you don't know in this, convert into decimals and do it. It's okay because it's graphing. You can do in decimals. So 0.75. So this was 0.5. He's taking 0.75. That's correct. Take anything 1 to infinity. 1 to infinity. Take any number. I take 2. I take 2. The immediate whole number after that. Now what you're going to do is put these values in the original function and find the value of y. So you had fx as 2x minus 1 over x minus 1. Let's put -1. What happens? I have to find f of -1. So you get 2 of -1, -1 over -1, -1. You get -2, -1, -1, -1. You get -3 over -2, which is basically 3 over 2. Or 1.5. I convert it into decimals. Let's put 3/4. 3/4, if you don't know, convert into decimals and then do it. Put into decimals and find an answer. Everyone, I want you to do it. I want you to find the value of these two. Put into function and tell me the values. Eduardo, I need the answer for when you put 3/4, what do you get? Hugo?
Yeah, so for the top, you get 1.5.
For which one? 3/4?
I'm sorry, I'm working through it.
Sorry about that. Just that something wrong with my mic.
Okay, Eduardo, what did you get for 3/4? Did you work on it?
I'm kind of getting a bit lost. Yeah, sorry. Couldn't respond.
I think I got 2.
You got 2?
It's
I think
negative
so.
0.3.
Aren't you
Yeah.
supposed to get -2?
Well, after I divided everything.
Let's see.
Oh, I don't know why I divided. Sorry.
Yeah. You should get -2. You should get -2. And you put 2, you will get 3. Make sure you're getting these answers. If you're not getting, let me know. I'll do it for you here.
Yeah, sorry, I forgot my negative sign when I divided.
Yeah, perfect. Yeah. Anyone else who did not get these answers? For 3/4, you should get -2. For 2, you should get 3. Plot those points. Let's plot those points. -1, 1.5, it's gonna be here somewhere. Okay, I found it here. Okay, then you have 3/4, which is in between these, you get as -2. So it's gonna be here. Okay, and then you took 2, you got as 3. It's gonna be here. That's it, you're done. After this, you just have to graph it. Note, my lines will not cross. My lines will not cross. So they're gonna come very close to this asymptotes. Cross the points, turn. Similarly, it's gonna happen on the other side. It's gonna go like this, cross the point and turn. That's how your graph looks like.
Still gonna do another example for this, right?
Yes, I'm gonna do more examples. Yes.
Can you clarify why the 3/4 is -2?
Okay, yes, -2, yes, I can clarify that. So let's see. I'm gonna do here. So your function was fx as 2x minus 1 over x minus 1. and you had to put x as 3/4. Let's do it. So you get f of 3/4 as 2 over 3 times 4 minus 1 over 3 over 4 minus 1. We got this thing. Let's solve here. So 2 times this becomes 6 over 4 minus 1 over 3 over 4 minus 1. Okay, let's see this. What is this thing? What is this thing? Let's solve. I cannot subtract unless I make common denominator. So what I do right now here, the denominator is 1 if it's nothing. So I multiply this also with 4, this also with 4. So it becomes 6 minus 4 over 4 divided the whole divided thing. With here also I have to do the same thing. Multiply by 4, multiply by 4. It becomes 3 minus 1 divided by 4. What does it become? It becomes 2 over 4 over, sorry, it's 4 over negative 1 over 4. That's what you get. Too many division signs. I can write it as like this, 2 over 4, and this thing is divided by negative 1 over 4. And how do you divide fractions? Division changes into multiplication and you flip the next one. It becomes 4 over negative 1, which becomes 8 over negative 4. You just multiply, which is negative 2. If this is confusing you, you can do it by, what do you call, make it into decimal. Make it into decimal and use your calculators. The good thing here is you can use your calculator. So put here 0.75 minus 2 times 0.75 minus 1, 0.75 minus 1. Write it in this way, use the calculator and you can solve. Any questions, anyone? Did you get it? Who asked?
I get it. Thank you.
Yeah, Ross. Yeah. Okay. So let's do one more example. I'm going to do is, so you are given fx as 3x square over x square minus 4. 3x square over x square minus 4. Okay. First of all, can I simplify this? No, you cannot simplify. Don't say, oh, it has x square, it has x square. I cancel it. No. From this x square, you are subtracting 4. If you are multiplying 4, then you could cancel. But because you are subtracting 4, if you are subtracting or adding something to that thing, you cannot just cancel. So you cannot do this. So what you're going to do is, next thing you're going to do is check for symmetry. Symmetry, how do you do is replace x with negative x. Let's see what you get. 3 negative x whole square over negative x whole square negative 4. So this becomes 3x square over x square negative 4. When you solve, what happens? If you compare your original function as this thing, it's the exact same thing. It's the exact same thing. So when I'm replacing my x with negative x and I'm getting the exact same thing, it is symmetric with respect to y-axis.
Y-axis.
Perfect. Yes, was perfect. It's symmetric with respect to y-axis. Since it's coming out to be exactly same. In the previous example, it was neither exactly the same, neither it was negative of the numerator. So we check for the symmetry. Next we need to check for is y-intercept. So your fx is given to be, I'm going to just write it here so that you know, 3x square over x square minus 4. Step 2. Y-intercept. For y-intercept, we just put x is equal to 0. So put x equal to 0. You get f of 0 as wherever you see x, put there 0. You get 0 square minus 4, which is 0 over negative 4, which is 0. Note, y-intercept and x-intercept, they are points. So you get here as 0, 0 as your y-intercept. As soon as you start doing step 2, I would suggest you to start graphing. Start graphing. in rational functions especially, I would say as soon as you get something, some point, start graphing, because you don't know what is point and what is line. So once you find it, then do it. If you keep on waiting like, oh, I'm going to do all the steps then do it, it's just confusing sometimes. So 0 0 is this point. I got my y-intercept as 0 0. Okay, let's see what's your x-intercept here. I need to find x-intercept. Anyone, what do you do for x-intercept in this case?
Numerator equals 0.
Yes, just the numerator equal to 0. So numerator is 3x square is equal to 0. You will not put the whole thing equal to 0. Just the numerator equal to 0. When you solve divided by 3, you get x square is equal to 0. Take square root, put a plus minus sign, you get x is equal to 0 only. Again, my point is this thing only 0 0. Okay. Step 4. Step 4. Anyway, it's like we have to find vertical asymptote. How do we find vertical asymptote? We put the denominator equal to 0. In this case, my denominator was x square minus 4. Anyone has any questions? Please, if I'm going too fast, let me know. So you put x square minus 4 is equal to 0. Solve. Add 4 both sides. You get x square is equal to 4. Take square root on both sides. Put a plus minus sign. You get x is equal to plus minus 2. Note these are vertical asymptotes. So they're going to be lines. They're going to be lines. So they're going to be vertical lines, or plus 2. X is equal to plus 2. Here. And negative 2. I'm going to draw a dotted line here. 2 and negative 2. Step 5. I need to find my horizontal asymptote. For horizontal, I need to see the degrees. So my question was 3x square over x square minus 4. Yes. In this case, my degree is exactly the same. Numerator degree is 2. Denominator degree is 2. Degree is the highest power of x. When it's equal, what happens? So n is equal to m. You get y is equal to the coefficient of the highest degree. The coefficient of highest degree is 3 in this case, divided by the coefficient of highest degree in this case is 1. So you get y is equal to 3. That means at y is equal to 3, it's going to be a straight line. Asymptotes, make sure you're making a dotted line for asymptotes. Asymptotes will be a dotted line. Any questions, anyone, till step 5? Step 6. Now I'm just gonna look at I'll make my x-axis now. X-axis I got here in the diagram here. I'm gonna look at my x-axis. See what are the points I'm getting here. Okay, negative 2, I have my asymptote, vertical asymptote. Then I have 0 0. At that also I have one of my points. Then I have 2 as my point. I'm gonna make a table. So my line is divided into 1, 2, 3, 4. I need to take 4 points. I need to take 4 points. You know, my axis divided into 4 parts. I need to take 4 points. Yeah, in one die. You have question?
No.
Yeah, okay. So when you do it, so take any point between before negative 2. Anyone, any point. Negative 3. Negative 3. Between negative 2 and 0. There is
Negative 1.
Negative 1. 0 and 2 you can take 1. Between 2 you can take 3. Now solve this, in the original function, put those values and get it. So you had 3x square over x square minus 4. First I'm going to put as negative 3. Let's see what you get. 3 times negative 3 square over negative 3 square minus 4. It becomes 27 over 9 minus 4. What do you get? 27 divided by 5. Convert into decimals. If you don't know, it's a convert into decimals and get your answers. You get 27 over 5. Put -1. So you get 3 times -1 square over -1 square minus 4. You get 3 times 1 over 1 minus 4, which is 3 over -3, which is -1. Note, when you put 1 also, since it's a square function, you're going to get the same thing. You can solve and check. You can solve. I'm just giving an answer. You can always put the values and check for 1 and 3 also. Then these are the points. Let's plot those points. -3, 27 over 5, which is basically what? 27 over 5 is 5 is a 25, 5.4. 5.4. So you're getting -3, you're getting 5.4. Let's mark. -3 is here, and that's 3, 4, 5. 5.4. It's gonna be here, somewhere here. Then you're getting -1 as -1. Okay, -1 as -1 here. Okay. Then you're getting 1 as -1. 1 as -1 here. And then you're getting 3 as 5. Okay. Here. Plot those points and graph it. So my graph is gonna go very close to the asymptotes, but it will never cross that. Similarly, in this case, it's gonna go very close, but never cross here. And then here also, it will go like this, cross the points, and never cross. Any questions? Any questions with the graphing of this thing, rational functions? Everyone got it?
Wait, can you see the coordinates again?
Coordinates? Oh, I'll show you. Any other questions? Anyone with graphing?
Okay.
So I guess tomorrow, do you still have doubts on this thing or no? Did you guys get this graphing? Got it? Okay. So tomorrow, whatever we did in polynomials and rational functions. So graphing of polynomials and we
Today's
did.
Thursday.
Yeah, Eduardo, yes. You have question?
Today's Thursday.
Oh, today is Thursday, yes. Yes.
Today's Thursday. Okay, we're not gonna have class tomorrow.
We don't have class tomorrow. I'm talking about the quiz. I was about to say about the quiz. So if you tomorrow, so whatever we did for rational functions, so far it's a graphing, finding the zeros, the three theorems we did, the 3 theorems. The remainder theorem, the factor theorem, and finding the possible zeros. These 5 things, you're gonna get the quiz on that tomorrow. You will have whole day to take the quiz. You don't have to show me any work. You will take it on my lab. I'll be posting the quiz on my lab. Also, I'll be assigning the homework regarding today's. I'll be doing it right now. Anyone has any questions? No? Okay. Thanks, guys. See you on Monday. If you have any questions, just email me.
You.
Bye.
Thank you.
Have a nice day. Bye. If you have questions, stay back. I can always help. Any problem with the concept, anything.
Thank you.
Yeah, you're welcome, Edward.
Thank you.
Hi, Joshua.